everyone. Um, on behalf of IEEE PLS SBC HBTU Kanpur, I extend a warm welcome to all the participants and to our esteemed speaker, Professor Sanjiv Kumar Sir, to day 2 of the 2-day MATLAB and Simulink workshop for electrical engineers, organized as part of the ongoing PLS Day celebrations 2026. Before we begin today's sessions, let us take a quick look back at what we covered yesterday. In session 1, we were introduced to MATLAB and Simulink, covering MATLAB programming, engineering computations, model creation, and simulation fundamentals. In session 2, we explored electrical circuit modeling, including RLC circuit simulations, circuit analysis, system responses, and single phase and three phase modeling in Simulink. Today, we will build upon these fundamentals and explore more advanced applications. It is now my privilege to invite Professor Sanjeev Kumar Sir to kindly proceed with the session. Sir is a professor in the Department of Electrical Engineering at HBTU Kanpur and currently serves as the Dean of International Student Affairs and coordinator of the HRD cell. With over 19 years of academic and industrial experience, his expertise lies in power electronics, electric drives, multi-level inverters, and electric vehicle applications. He earned his PhD from IIT Roorkee and has published extensively in reputed international journals, including IEEE Transactions. He is a senior member of IEEE, a fellow of IETE, and the faculty advisor of the IEEE Power Electronics Society student branch at HBTU Kanpur. With immense pleasure, I now invite Professor Sanjeev Kumar Sir to kindly proceed with the session. Over to you, sir.
Thank you, Dhruvi. Now, dear participant, as Dhruvi said, we have covered all .m programming and Simulink fundamental. Today, as per schedule, first of all, I would like to show you the my screen and then show you the. It is advised to all participants. Please don't turn on your. Tushar will take care of her. Just mute. See, as per the schedule, what we have to cover today, let me show you. This is the schedule according to which we have to cover these things. That means diode rectifier modeling. It is, although it is mentioned diode rectifier modeling, but we will also see the control rectifier as well, single phase as well as three phase. We will try to see the DC-DC converter, inverter, single phase and three phase, and also the multi-level inverter. Not only this, in session 4, which would be start after this session, there we will see some higher level simulation like EV battery charging system and BMS system and induction motor speed control, etc. I'll just see how much time I have. According to that, we will do. Right. So, without wasting the time, let us start. Just give me a second. Let me close this. Okay. Now, my screen is visible to all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. So let us start with our rectifier, which is a single phase rectifier. Let us start. Let it open. Let us open it once again. Just give me a second. I don't know why in the WhatsApp group people keep on giving their name. As I already said, for feedback session, we required 10-20 people at most. But somewhere around 60% has given their name. I always used to say one phrase that is common sense is the sense which is not common in all. So this is a very simple circuit of single phase half wave rectifier. Single phase half wave rectifier. Huh? Very simple circuit. I hope it is visible to everyone.
Yes, sir.
Push up and see, as I said, please join timely. Every time this message pop up, it irritate me. And one thing I wish that any participant just unmute yourself and we I will ask the question and you have to tell. Then only the benefit of this real hands-on workshop would come. Right? Any one of you, just unmute yourself. So from where we will get this AC voltage source? Can anybody tell?
From transformer, sir.
No, not from
AC like power
transformer.
system.
Yes, anyone. See,
AC generator.
uh, just wait, just wait, just wait.
Alternator,
And
sir.
okay. So many response. Everyone wish to respond, but it is from the sources. All are responded wrong. It is from the sources. Sim power system. I'll show you from where we have to take this. Just click the simulation library, Simulink, and there you have to go in the sim escape and then you have to go sim power system and in advanced version you will find that this is some fundamental library. There they have put it this. Only place is change, but the fundamental remain the same. So in sim power system, if you look at the electrical sources, just see here it is. This is the current source and this is the voltage source which we have taken, right? I'll show you the model, then I'll ask you. After that, I will show you the real position from where I have taken, right? And try to do the only one participant. Just unmute yourself and turn on his or her camera, so I and you would be come on the focus. And the session is live, so it is a little bit interactive workshop, not like monologue. I just keep on saying, and you are just listening. Now, come to the second thing, that is the detailed thyristor. From where I have taken detailed thyristor or thyristor, these two are the same block. You always prefer this one. Yes, from where I have taken, can anybody tell? And it would be great if only one person turn on his or her camera, or just answer. From where I have taken this?
Sir, actually it is from power electronics device.
Yes, absolutely right. It is from the power electronics device. Very good. And where I have taken this component, RLC branch, where I made this as a resistive element and having the value 10. Can anybody tell from where I have taken this?
From elements, sir.
Absolutely right.
Electrical
From
element.
the absolutely right. Absolutely right. From the element of sim power system. Then from where I have taken this voltage measurement and current measurement?
Measurement block.
From yes, measurements. Absolutely right. Now I have covered all the element of which I have make or which I have selected only three component, that is the pulse generator and this scope and this scope, and one this block which is the mux. Can anybody tell from where I have taken the scope?
From sync, sir.
Absolutely right. From the simulation, Simulink sync. All these element, from element I have taken this series RLC branch. From measurement I have taken voltage and current measurement, and from sync taken the scope. And from where I have taken the mux? Where I have taken the mux? Anybody answer? I have taken it from signal routing block. Just see, here we have mux, means two signals are coming and outputted here. It's very problematic. So this is how we are collected all this, right? And from where I have taken this, when you click the sim power system, you will get this block there. So you have to put it here. Now just run the simulation. Just run the simulation. I always used to say my student, before pressing the run button, this button, before pressing the run button, you must know the expected output. अरे सर क्लास में है, लाइव चल रही है, क्लास में है, लाइव चल रही है सर क्लास, जी जी. तो so this way, what I was saying, before pressing this run button, you must know the expected output voltage. Can anyone tell me what would be the expected output voltage and current waveform? Any one of you, those who are in power yes, please.
It is, sir, DC, but it is thyristor, so whatever firing angle, we get the voltage from that firing angle, that current.
Absolutely right here. What's your good name?
Aniket, Aniket.
Very nice. Aniket, you are absolutely right. We will get the output voltage for the half of the cycle because it is half wave rectifier. Now just check what we are getting. This is what we are getting. Uh, This is what we are getting. Just see. This is the thyristor currents, and let me open this load voltage and current. Why it is not coming? Just voltage measurement. Why it is not coming? This. Uh, okay. Just give me a second. Let me run it once again. MATLAB itself a bulky software, and we are running on Meet. So just give me a second. Okay. Now open this load voltage and load current. Let us expand this. Here you can see this is the output voltage only for half of the duration, and I hope it is visible. It is from 0.38 to 0.39, means it is 0.01. 0.01 is 10 millisecond. As you can see, the supply frequency is 50 hertz. That means 20 millisecond. To complete 20 millisecond, this one cycle, it required 20 milliseconds. So half cycle would be of 10 millisecond, and that you can notice here. It is of 20 millisecond, half of the 20 millisecond, and the current is followed by the voltage, and it is V by R. So you can see the peak is of 100 volt. Let me show you. Peak is of 100 volt, and the value of resistance which we have taken is 10. That means 100 by 10, it is 10 ampere. You can see here, it is 10 ampere. I hope all these figures are visible and readable to you if you are using your laptop or desktop. I am not sure about if you are using on this mobile. Can anybody tell? Is it okay?
Yes, sir. It's visible.
Yes, sir, it is okay.
Fine. Now, suppose we wish to run for the firing angle of 90-degree. Suppose we wish to run for the firing angle of 90-degree. Can anybody tell what change should be done? What change should be done?
Up to firing angle, voltage or current is zero.
At firing angle 90, voltage and current will be zero. Why? Why is it so? No, it will not zero.
No,
Why
no,
it
no,
is
sir.
zero?
I am saying up
Yes,
to
yes.
90 degree zero. Up to 90. After 90.
Yes, yes, yes. Yes, yes. It is. I request to organizer, volunteer, that keep on watching this MATLAB group. There are so many students are saying that they are not able to join. Take care of them. Take care of them. It is not possible for me to deliver the talk as well as looking after this WhatsApp group because it distracts my thought process. Now, what I am asking, what change should be done and where it is to be done. Can anybody unmute yourself or and discuss with me? We will do some exercise, and that some exercise will give you a great idea how to run a MATLAB simulation in Simulink. Because the concept, once the concept is clear, now you can run any difficult simulation on MATLAB. So, anybody tell what needs to be changed to get firing angle 30 degree? Any one of you? We have at present 108 participants. In fact, 113, 113, 113. Can anybody tell what needs to be changed to get the output voltage for firing angle 90 degree?
Pulse generator pulse.
Yes, the pulse generator, that means our pulse should be generated at 5 millisecond. 90 degree means 5 millisecond. 20 means 360. 1 upon 50 is 20 millisecond. 1 upon 50 hertz is the frequency. So time is equal to 1 upon frequency. Time period is 1 upon frequency. 1 upon 50 is 20 millisecond. Within 20 millisecond, the entire cycle is covered. That means 360 degree. So 180 degree would be covered in 10 millisecond and 90 degree will be covered in 5 millisecond. Now let us have the look on pulse generator. This I have taken from the Simulink block set, the pulse generator. Right? You can see what are the parameters are here. Its amplitude, you make it 1 or 5, doesn't make any difference. And the time period is 50, so hertz is the cycle frequency, so it is 1 by 50. And pulse width is 1%. See, to turn on the thyristor, a small mono shot is more than sufficient because the pulse duration should be such that the thyristor current should reach the latching current, and latching current value is very less. So a small mono shot, when you make this circuit in the hardware using operational amplifier and all, then you should remember all this thing, right? You have to generate a simple mono shot. So 1% or 5% is more than sufficient. Now what you want to do, you want to provide the delay of 5 milliseconds. You want to provide the delay of 5 milliseconds so that at 90 degree it should be trigger. Just give the value 0.005. It is 5 millisecond. It is 5 millisecond. Just apply. To OK. This single simulation, you will learn a lot of things. Now run the simulation. Just see. Mr. Kushar, keep on waiting the guys. Like Anand Jaswal is waiting. Now you can see that the waveform is like this. Waveform is like this. Absolutely fine. It is triggered at 90 degree and going up to 180 degree. Then for the remaining 180 degree duration, there is absolutely no voltage or the current. Right? Now, let us have a look on thyristor voltage and current. Can anybody tell what would be the thyristor voltage? Thyristor voltage is always anode voltage minus cathode voltage. So whenever the thyristor gets on, only forward voltage drop, which is 0.8 volt, will occur across the thyristor, and whenever this is off, the entire supply voltage will the thyristor. Let us see. Just see. For from starting 0 to 90 degree, the entire supply voltage is coming. And for remaining period, and for remaining period there is no no voltage. There is from 0 to 90 it is not conducting. From 0 to 90 it is not conducting. So entire supply voltage is coming across the anode to cathode. And at 90 degree you trigger the thyristor, so the current starts flowing, and the voltage drop across the thyristor is zero point 0.8 volt. Let me extend this. It is this voltage drop is there, very small voltage drop is there during the period when it is conducting. Ideally it should be zero point 0.8. Ideally, since I have not designed this snooper circuit parameter, that is why it is like this. That is why it is like this. Hmm? If I change this, like I'll make it from nano to micro, then you will see the this voltage will get changed, the reverse voltage and all. Just give me a second. Very minute observation is required here. I'll show you. You can see now. You can see now. Here you can see once the thyristor is on, the output, sorry, this is the output voltage. Just wait, let me open this thyristor. This is the thyristor voltage. This is the thyristor voltage. Here you can see the supply voltage is occurring up to 0 to 90. Then after that, very small voltage is coming. Very small voltage is coming. Right. 0.24. Right. Very small voltage is coming. Now, let us make this RL circuit. Let us make it RL circuit, and I am taking very small value, 1 millihenry only. Now run the simulation once again. Run the simulation once again. Let us see. Now, can anyone tell what would be the voltage, output voltage waveform? I mean, it will start from 90 degree, and up to what angle it will go? It will go from 90 to 180 or more than that. Can anybody tell?
Voltage is same as in case of only resistor, but current is changed in RL.
Okay, absolutely right. But my dear friend, voltage as well as current waveform both will change. Reason is inductor is having the property to oppose the change. After 180 degree, voltage would be the negative, but since it is having RL, so inductor current or the load current would lag from the supply voltage, means it will not be zero. I'll show you in the result. Let us see. Here you can see. Just see the supply is zero here. Let me zoom this. Let me zoom this. The vertical axis, so things would be more clear. I hope it is visible to everyone. Here you can see this is the 180 degree. This is the 180 degree. Voltage is passing to zero. Mr. Kushagra, please add deep mandal and all. Please add. So you can see the voltage is zero, but the current is not zero. My mouse pointer is visible to all of you.
Yes, sir.
My mouse pointer is visible to all of you.
Yes,
Yes,
sir.
sir.
Good. So you can see it is not zero. It will keep on flowing, and unless until the current is flowing, your thyristor cannot be turned off. That is why it is called current control device. You cannot make it off unless until the current flowing through this is less than the which current? Holding current. After holding current means below the holding current, thyristor get turned off. Otherwise, it will keep on conducting. And unless until the thyristor is conducting, the supply voltage is coming. You can see it is coming. And once it is zero, the output voltage is also zero. Now, let us increase the value of inductor. Let us increase the value of inductor. Let us make it 10 times greater. That means 10 millihenry. And I'll run this simulation only for 0.04. Let us run this only for 2 cycles. You just see. Even if you run this simulation 2 cycle or 20 cycle, doesn't make any difference. It is running. Just wait. Just wait. I don't know why. See, just see. Now you can see it is the duration of the current is little bit higher. So output voltage is for the longer duration. Output voltage is negative for the longer duration. Now I'm going to do a foolish thing. I'll make this inductor one hand. Just imagine the size of the inductor. Huh? I'll just make it 1 Henry. Can anybody tell what would be the output voltage waveform and current waveform? Can anybody tell what would be the output voltage and current waveform? No idea? Just see. Just see. Just see. Why it is happening? Why it is happening? I made the value of inductor is 1 Henry. Just see the current of inductor. Just see the current of inductor. It is like this. 0.1 to 0.4 and again 0.1 to 0.4. How it is possible? How it is possible? How it is possible that the current is coming from here and it is going up to this much 90 degree. But how it is possible? Because the value of inductor is quite high and the negative current is because of this snoober. This snoober. Thyristor current cannot go from cathode to anode. But in the parallel of thyristor, there is RC circuit, snoober resistant and snoober capacitor. So from there, see, when thyristor is on, that RC is bypassed. When it is off, that RC is come into the picture and the resonant current is flowing. I just show you this to make your concept clear. How important it is to design the snoober. How important it is to design the snoober. Right? Now let us do one more thing. Make this 20 millihenry, 20 e to the power minus 3 and run this, let us say, for 1 second, so that several cycle can come. And let me check whether I'm saving this or not. I'll show you the FFT analysis as well. That is TSD and all. Okay. So here you can see that this is now absolutely fine. At 9 degree it is triggered, the current is here 0 and then it is 0. Now just check, just double click the power GUI block. Just double click the, then click the FFT. Just see this FFT analysis. Is it visible to everyone?
Yes, sir.
Good. Now in FFT analysis, I haven't saved the waveform. So what you have to do, you have to take this waveform in the workspace. Let me do this. Go to the history, save data to workspace, give some useful name. You may give name as Sanjiv, but that is of no use. I'll give it load voltage and current, LOAD, any name you can give, like your name as well, and save it structure with time, so that with the time stamping, that data is in the workspace. Right now you have to run the simulation once again, so that data is saved in the workspace. Now just double click this, go to FFT analysis, and here you will find this load VI, right? Here you have two signals. The first one is voltage and the second one is current. Right? Now you can see start time I'll make 0, number of cycle I will take. Whether you take 2 cycle, 4 cycle, doesn't make any difference. 3, and simulation frequency, system frequency is 50 hertz. Now display. Just see that TSD is quite high. TSD is quite high, 75%. These are, let me make it the same as maximum frequency, and this is the bar related to this. And let me also make this not in hertz, display. Frequency axis is the harmonic order. Now you can see. Now can see in the current, this is the harmonic spectrum. Can anybody unmute yourself? I would like to ask few questions. Very fundamental question, but very important, related to your research. If you really feel the power system or power electronics, just unmute yourself. Anyone? Yes. Anyone?
Good
Just
afternoon.
unmute yourself. Yes, please.
Sir, there are two. Sir, myself, Amrita Patnaik. I am from
Yes,
Odisha.
Amrita.
Okay.
Great.
Sir,
Yes,
sir,
Amrita.
there is one question. whenever you save
Yes.
the data, actually the screen was not visible. Okay, the first thing was that one I mentioned in chat box, but no one was replied. The first thing
Actually,
is this one.
see. Oh, just a minute. Kushagra, please note the thing that you just keep on checking the chat box as well. In case some query is there, you just tell me. Otherwise, I request to all participants just unmute yourself and tell me. Right?
Okay,
Because the chat box might be anything, maybe skip. I'll show you again that
yeah,
thing. Number one.
so
Thank
let
you.
me
Yes,
complete
please.
first. So
Yes.
the first thing is when you save the data in structure with time, after that I am not able to see the what are the changes you did, because sometimes when in the 2025 MATLAB 2025 when I run the program, I am not transfer the save the data. After save the data in structure with time, it is not visible at the FFT analysis. That was the query. That was the query, but I have not seen how did you perform that one. That one, and I think
Okay.
I missed that portion also.
I'll show you. I'll show you. Fine. Anything else?
Thank you, sir.
Anything else?
Uh, so second one is as you are preparing, as you showing the half wave rectifier. So there are one more thing. Whenever you go for the explain the details, there is one missing term. You actually explain first. At that moment, the blocks are not open. Like just get pulse. Another one is the value of voltage, what you have mentioned, and those small data is missing. Okay, somehow when you are asking the question ke what should the output value? Okay, there is a question ke what is the input value? So according to formula, we can also find out that value
No,
also.
no, 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 no. Listen, what I mean to ask what is the output means output waveform. Here, there is no point to saying the value. The reason is you are operating this rectifier using the AC supply. So output is always follow the AC supply, but the question is at from what instant, from which instant it start following. It start following once the thyristor get on. As simple as that. And when it is stop when the thyristor get off. Means turn off. That is the zeal of asking that question. It is not give what should be the value 10 volt, 20 or 50 volt. It is not like that. What I mean to say, just tell me what should be the expected output voltage waveform on the scope. That's it. Right?
Okay. Okay, so one more question. Sometimes when you
Hmm.
run the program, we are not getting the desired output because somehow it is nearly equal to, it's not here nearly approx to the exact value,
Is
or
that
somehow it is
see
less than the exact value.
See, the reason is you what we are expecting. For example, if the input supply is 100 volt, we are
Hmm.
expecting the maximum of the output voltage would go up to 100, but it would not be the case. The reason is there is thyristor, and always there is a drop in the thyristor itself. Number one. Second thing, you might notice during turn off period, the exact voltage is not the same of the supply voltage. Why? Because when the thyristor is turned off, then there is no current. Fine. But there is a circuit. How that circuit would become? It is because of parasitic element of the thyristor. Means not only that, there is also the snooper circuit in
Hmm.
parallel of the thyristor. So you just imagine the circuit. The supply is there. Then there is a parallel circuit which is across the thyristor. That is RC circuit. Then you have RL load. So this circuit is more or less become like your RLC circuit,
Fine, sir.
isn't it?
Thank you.
Right.
So,
So from there, that voltage is get little bit distorted. But when we design the snooper circuit properly,
hmm.
depending upon the characteristic of thyristor, you will get very fine waveform. Right? That
Okay,
is
sir.
the design aspect of the. For example, if you look at this waveform, there is a
Hmm.
small rise in the current. You can notice before 0.04. My mouse is
Yes,
there.
yes. Yes,
Right?
sir.
So
Hmm.
how it is possible? How it is possible? It is possible just because of that RC circuit across the snooper, then RL circuit, then supply. It is not through the thyristor. isn't it?
Yes, sir. Okay,
It is because
sir.
of that.
Okay,
Yes,
sir.
please.
Another question is, the
Yes.
year of 2013, when I actually that time I did my MTech. That moment, I think
Okay.
2011, I MATLAB 2011. During that
Fine.
moment, our sir told me that you just change the configuration of the I think page or solver so that you can get the desired output. I think there are two,
No,
three things are there.
yes, listen. Your sir was absolutely right. If you attended my yesterday lecture, I have already told you for power electronic simulation, you have to choose the 115S. You can see my simulation. I have already selected ODE 15S. If you select some other solver, then your
Yes,
waveform will be disturbed, right?
yes, yes,
So
yes.
since I have already told you, I am in yesterday class, that is why I
Mm.
have already selected the best solver for my simulation, right?
Mm.
And you are
Yes, yes.
absolutely, as well as your sir is also absolutely right. You have to select the solver properly, as I told you in yesterday lecture.
Okay, so last
Anything
question.
else, Amrita?
Yes,
Of
yes, sir.
course, I love
Actually,
to give the answer.
sir,
I
actually,
love to give the
MATLAB
answer.
version
Please.
is changed day by day. Okay. So when
Yes,
we prepare a 2024 version or 2023 version, there are new thing was not mentioned, that peak to peak value. I think del T and del Y, those things are mentioned in the
yes,
2025 MATLAB.
yes,
Okay,
yes,
so little
yes.
bit confusing. It is taking so many time because lots of research papers are not mentioned that one.
I tell you. See, Amrita, when I started this MATLAB, because I am from the industry, this HBTU is my first teaching job. I joined here in 2007. Right?
Yes, sir.
Since the person came from industry, we have some different thought process. Right? When I
Yes, sir.
started teaching, then I realized if we demonstrate simulation to student, it will give them better understanding. So I started with 6.5, MATLAB 6.5, MATLAB 6 is the version, and the latest version at that time was 6.5. So I started from there. I'll show you. Actually, time is very less. That is why I am not showing. Is from there MATLAB 7, MATLAB 10, MATLAB 11, MATLAB 13, all version I have. I keep on updating myself. Like nowadays, people are not working on .mdl. They are working on SLX, which is
Yes, sir.
based on XML, small size file, right? But
Mm-hmm.
since the real-time simulator, which is very costly equipment, somewhere around 45 lakhs we have purchased, and that is compatible with 13 and all. So I am not using that higher version only because of that reason. But offline, I also keep on updating myself, and that is the requirement of being a teacher. That you should always keep up yourself update. Then only you can survive internally. Otherwise, you are sarkari damad, just do ash. But if you behave like as a teacher, which I believe an extraordinary person, a teacher is an extraordinary person because you have to think about your student all throughout 24 hours, entire 365 days. Then you are supposed to be get updated. If latest version come and your hardware, that means your computer, if you look at the latest version, it is 18 GB, 20 GB memory space is required to install that higher version.
Yes,
That is
sir.
sometimes very difficult. That is sometimes very difficult. That is why MATLAB also give you the provision. You can save your simulation in the old format. I'll show you that thing also. I'll show you
Okay,
that
sir.
thing also. So it will make
Okay.
the compatible in the .mdl file, and your lower version MATLAB can run that. Right?
Yes, sir. Yes, sir. Okay.
Anything else?
No, sir. No, actually, sir, I am a PhD student from, sir. I have completed my PhD in material science. That's why I am working on MLI. So it is little bit difficult for me because I left this MLI in the year of 2013. Okay, from after
MLI means
13.
multi-level inverter.
Yes, yes, sir.
You just follow my channel. There are lecture I have taken at NIT Surat. Somewhere around 2 hours 57 lecture. All simulation is being done there. You just
Sure,
check.
sure, sir. Sure.
right?
Okay.
And in case I'll also show you the slide where my contact details are given, and even in WhatsApp you have my contact details. You
Yes,
can
sir.
contact me via mail or WhatsApp, anything. If I am able to do, I'll feel happy, right?
Okay, okay, sure, sure, sure. Sir,
Okay.
there is my query. This one is the query.
Now, which one?
This one, sir, FFT analysis.
This one. So now come to this. Now
Okay,
we
sir.
will do the FFT analysis. Acha, before that, I should tell you how this waveform is coming. For that,
Yes,
what
sir.
you have to do, dear? You have to save your data in the workspace. You just go to the history and there save data to workspace with any name. For example, I have given load underscore VI so that it show that
Hmm.
load voltage and current. You can give your name or my name or anything you can give, but it should be meaningful. That is why. And there are three options: structure, array, and structure with time. You have to save. If you do the FFT analysis, you have to save it structure with time, because it will take the value, or it will keep on the keep update the value after one sample time, which is at present 50 microsecond. So after every 50 microsecond, it will keep the update of the data, right? So in that way it will operate. Now let me show you the FFT analysis. And very interesting fact you will see. You will see very interesting fact which we used to tell our student in book or blackboard or PPT, but here they can practically observe. See, it is the half wave rectifier. Can anybody tell why half wave rectifiers are not preferred? Can anybody tell?
Sir, it's
Yes.
all about the switching losses.
Switching losses, see, only one switch is there, so switching losses is minimum. But the problem is, see, the supply is coming from the transformer,
Source.
distribution transformer,
Hmm.
right? Source means distribution transformer. Whenever you run the industry or anything neither you use supply, it is coming from some distribution transformer.
Hmm.
Whatever the current is taken by the rectifier is from the supply system, and there is a transformer. So only for the half of the cycle it is drawing the current, and not for the half of the cycle. So your transformer get DC saturated. And here you can see the fundamental zero. Zero means fundamental is one means fundamental, that is 50 hertz. Then after that all are the harmonic, and there is also zero component. What is the meaning of zero component? Zero component means the DC component is injected in the thyristor, in the transformer supply system because of your rectifier. That is why half wave rectifier is not preferred, because they inject this DC component. Not only that, since the waveform is not symmetric, waveform is not symmetric. Positive cycle, there is a waveform, negative cycle almost zero. So there are even harmonic as well. You can see second, third, fourth, fifth, sixth, all other harmonics are there. All other harmonics are there. So that is the problem. That is why it should not be used. That is why it should not be used. Isn't it? Now we will open different simulation, that is, just give me a second, just give me a second. I hope participants are enjoying this online workshop, even though we are not in person facing each other, but I am trying my level best to give you the real feel of simulation. Just see. Or I should run the full wave. Okay, I just show you this, then I'll show you the full wave rectifier. I hope the circuit is visible to everyone. If it is visible,
Yes, sir.
just give the reaction. Send some thumbs up so that I can notice you are in Jagrat Avastha or sleeping. The only PhD research scholar of mine. Okay, okay, okay. Okay. You all are watching. That is the good thing. Fine. Absolutely fine. So here you can see what this simulation is. Here is one transformer, simple linear transformer, which is having one primary and two secondary. That is called the central tap type transformer. That is called the central tap type transformer. Isn't it? Clear? Isn't it? Now, what I did, this is the transformer, this is current measurement, this is voltage measurement, and there are two thyristor, and there is a load, RL type load is there. Here, now run the simulation. Run the simulation. What is the expected waveform? Can anybody tell? What is the expected waveform? Aparna ji, now I am not asking the values. I am asking the expected waveform. So anyone can unmute.
Sir, in this, we got the result as same in diode-based rectifier polio, but negative cycle is there in case of full.
Yes, of course. Means positive as well as negative cycle in both half of the cycle. You will get the output voltage. Right? You will get the output voltage. Let us see. Let us see. Here you can see both the cycle, both the cycle, the output voltage is coming. I have taken the firing angle 30 degrees, so from 30 degrees the output voltage start to coming, and it is the continuous mode of conduction, and you can see the minimum value of the current is 0.8, right? The minimum value of current is 0.8. See, whenever we are using the RL load, let me close. There are so many windows. Let me close these windows. Close. Now I think all windows. Fine. Just see. भाई ये participant भी typical participant हैं. They keep on coming late. They keep on coming late. Here you can see. Here you can see the. Just a minute. Just a minute. Here you can see it is triggered at 30 degree and the value of current is quite high. Then the value of inductor is high. That is why current is in continuous conduction mode. There are three modes possible. One is critical continuous, other one is continuous, and the third one is discontinuous. Let us make this value of inductor less. Let us make it 1 millihenry. Now run the simulation once again. You can see the waveform is changed. The waveform is changed. Now what I want to show you, that is, okay, callback function. Let me check where is power GUI block. Just give me a second. Ah, here it is. Now just check the FFT. Here you can see load voltage VI. Just see. Actually, this mm, this block is, let me stop the screen sharing, or what should I do? Just give me a second. Just give me a second. This block is, just give me a second. Let me stop the screen sharing for a moment and pick this. Just give me a second. So many waveform and voltages are opening. So it is hanging. Now it is fine. Just give me a second. I'll show you now. Yes. Let me check. This data is not saving. So let it save VI with structure with time. Okay. Now I should run this simulation once again. Run this simulation once again. Fine. And then again check the FFT. Here you will notice that DC component which was coming earlier, this is VI. Oh, only voltage is there. Just give me a second. Where is the current measurement? Because we have to check the current, na? Load current. This is load current. That means second input. Okay. Second input. Just give me a second. This. Make this 50 hertz. FF window. Starting time, let us come, the starting time should come. I'll take it point 0.1. 0.1. Number of cycle 5. This is okay. So this is the current waveform. Same as the maximum frequency bar relative to this, and take the harmonic order on x-axis. Just see.
Sir,
Yes.
sir, this start time is matter. Well, it is need to provide Can we provide it 0 instead of 1?
Where?
In FFT analysis, where you mentioned the start time and number of cycles, you put
No,
one.
no. See, I'll show you. I'll give it zero and
Yes.
number of cycle. Let us make it one. Just
Hmm.
see how it is. Just see how it is. Just give me this FFT. See, the steady state is not arrive at this point.
Okay.
Have you
So
taken it?
during some web forms, from 0 to I think 0.2 milliseconds, till there is a distortions, lots of distortions. So,
Yes,
okay.
yes. Because see,
So,
whenever there is inductor,
hmm,
whenever either inductor or capacitor,
hmm,
there is transient state. They always take time to come under the steady state. If
agree, sir.
only resistive element, then there is no problem. I'll
Hmm.
show you here. Just give me a second. Just give me a second. Now see the voltage waveform and current waveform. Look at this. Look at this.
Okay.
In the starting, you can see the output voltage is also varying. This is the first cycle 0 to 0.02. This
Hmm.
is the first cycle. So this is the transient state. That is why I have selected the stage somewhere where steady state arrive. There steady state arrive. Look at here. All are similar in nature. Right? That is why I have selected. It is not like that you should select at one or two or anything. Depending upon the
Okay.
simulation. Right? Depending upon the simulation, whenever you get the steady state, select that time. Clear?
Hmm. Sir, one more
So,
thing. In the
please,
screen,
please. Yes.
sorry, sir.
No,
Actually, I
no,
have
no,
lots
not
of
screen.
questions.
Amrita, it is benefit for others as well.
Okay. Sir,
Yes,
in the
please.
screen, when you saw the waveform, voltage waveform, sometimes there is a question, what is the ripple? Okay, because you put an inductor and capacitor, somehow its ripples are reduced. But if you are
No,
using,
listen,
uh,
listen, listen. Amrita, I got the question. Listen.
hmm,
At present, if you look at the circuit, let me select
yes,
this.
hmm,
Did I use any filter circuit here? Just check.
no, no
Just check.
filter, only series inductor. If you can say it is a low part, then it's fine. Otherwise, you can say it's a
This is
inductor
the
is
load.
the,
See,
okay,
this is the load. So it can't be treated as the filter, right?
hmm, hmm,
When you use the filter, then LC circuit should come. C come in the parallel and L come
hmm,
in the series, right?
series, yes, hmm,
I am not using any filter circuit. And whenever they ask about the ripple, what you have to do, you have to measure the voltage, output voltage with AC measurement. Try to understand. Output voltage is DC, isn't
hmm,
it?
hmm,
The
hmm,
rectifier output voltage is DC. If
hmm.
you measure the AC component of DC voltage, what it will? It will be the ripple only,
Sir,
isn't
in the
it?
waveform, can you show that one? In the
Of
waveform,
course,
there is a,
of course. Just okay. Let it move forward as well as the your query is considered. What I am
yes,
going
sir.
to do, I am going to take the full bridge rectifier rather than using this transformer central tap. I am going to use the full bridge rectifier, and there I'll put the capacitor at the output side and show you the ripple and all. Right? Let
Sure,
me
sir.
open that circuit. Let me open that circuit. I'll close this. Otherwise, what will happen? The target which I am thinking to cover within these 3 hours, that will not be achieved. Let me open that. That let me open. Close this Okay, just see. 1:30 तक का time है, fine. So this is the full bridge rectifier. I'll show you. Here you can see my circuit. I hope it is visible to everyone. It is visible to
Yes, sir.
everyone. Fine. Now what I did, I took the fourth thyristor because see the central tap rectifier is always undesirable. The reason is it required a transformer and it is very difficult to have the exact central tapping. So one cycle voltage is different, half of the cycle and half cycle voltage is different. That is the problem. Other problem, the device which you are going to use, that has to be twice the rating of the output which you are getting, because the PIV is just double as the input, right? So all those problem is having. So what we prefer, we go for full wave rectifier. It is not bulky because the transformer is reduced, but only the effect is this, that you have to generate the 4 pulses. And that is also very simple. You have to generate the pulses for this T1, T2 at the same time, T3, T4 at the same time. I'm not going to teach power electronics at this stage because the direction will change. I'm come to the simulation, assuming that everyone knows about the power electronics wonderfully, right? So here I have taken the resistive load. As this is the load. Now first run this and then we will use the filter, right? So the Amrita question would be carried out in that way. Just see what is the voltage. This is the output voltage. Absolutely fine.
Yes, sir.
It is absolutely fine. Now you can see the ripple. Voltage is starting from zero, then going to the peak, then coming to zero. But what we want? Why we want a straight line if it is DC. So for what we will do, I just put one capacitor and just put, I am not designing it properly because the time is not that much I have. Let us say 2200 microfarad, which is easily available capacitor, standard capacitor available in the industry. That value I have chosen. Now run the simulation without any change. What I did, I simply put one capacitor and run the simulation with all parameters remain same. Now what would be the expected output voltage? Just see, it should be a straight line with some ripple. Look
Yes,
at this. Look at this. Again, the positive cycle and negative cycle is coming, but in the previous case, it was starting from zero and going to the peak. But in this case, it is starting from 70 volt. Output voltage is varying from 70 to peak, let us say 220. It must be 220. 230 volt. Just see, it is 230 volt. Supply voltage is 230 volt. So it is going from 70 to that much. Now just increase the value. Just increase the value. Let us make it 3. Let us make it 3. That means 1000 times I have increased the capacitor value. Now run the simulation. अभी क्या जा रहा था? It was 70 to 230.
230.
Now just check. 70 to 230. Now just check again. How beautiful it is. How beautiful it is. It is from 0 to 100 volt and steady state is not reached. Steady state is not reached. So let us run the simulation for 10 seconds so that you can see the straight line. Just give me 10 seconds. Within 10 seconds, you can notice. And Amrita, I am going to show you very interesting thing.
Sure, sir. I'm waiting.
In the same. Now it is fine. Just
Yes.
check. Now,
Yes,
now
sir.
voltage is ripple free. Are you agree now?
Yes, yes, sir. Sir, when you vertically drag, so we can see the ripples. Very minimum, I think.
Ah, yes, absolutely right. It is not possible to remove the ripple even if you use 1 farad capacitor. I'll show you. You are absolutely right. That is the thing every researcher must understand. Now see the ripple. The same type of ripple is coming. Arey wah wah, jadoo hua. Wonderful. Again, the waveform of the ripple is same, but the magnitude. Look at the magnitude 122.25 to 122.4 means 0.15. The ripple in the voltage is of order of 0.15. Otherwise, it is absolutely straight. Just see. Just
It's
see the
looking like in
voltage.
a straight line. Agree, sir.
Yes. And 0.15 in the scale of 120, it is nothing. 0.15 in the scale of 120, it is less than 1%. It is absolutely fine. But what is the cost of this straight line? You just see.
Extra capacitor.
2200
Yes.
milli. Huge capacitor is required. Big capacitor is required. So you should compromise between the quality of output and the investment. Quality of output and investment. See, we all are engineers. And whenever we are going to sell our product, the last question from the purchaser come, what would be the cost? You will start telling the advantage of your product, sir. We are having this much ripple free, it is robust, it is handle short circuit, everything. Then the again last question will remain same. What would be the cost? So you should keep this thing in mind, keeping the view of the customer that whatever the things you are going to invest in your product, it should be worthy. Even if you reduce the ripple so well, what is the use of using this much heavy capacitor? It is of no use, right? That thing we can see in the simulation. It is very difficult in hardware. Nobody
Yes,
is
sir.
going to invest this much money. That is the beauty of MATLAB. That is why I always used to say to my student,
But
you can
sir,
do
if
anything. Yes.
it is connected with the real-time hardware, so that we can manage the error.
Yes, see, that facility is also provided by using nowadays real-time simulators are coming. Opel RT, Typhoon Hill,
Yes,
PSCAD,
yes.
this power system. People used to, I just forget the name. Uh, I just forget the name. Power system. People use that thing. Real time RTDS they use, right? But for
Yes.
power electronics, we use this Opel RT system or Typhoon Hill, right? So that is the thing you can do in a hardware loop. You can control the things in real time. See, sometimes when you run the simulation, you might notice that the simulation time is 2 seconds, but it takes 10 minutes or 5 minutes, depending upon the complexity of the simulation. But if you run it on the real time simulation mode, on the real time hardware, FPGA based Spartan board and all, then you will find if you look at your watch now within 2 seconds, if you put the simulation time 2 seconds here, your simulation, no matter how complicated it is, it will definitely run in the within the 2 seconds, right? That is the beauty of that real time simulator. Now, do one more thing. That is, first of all, I'll remove this capacitor because my aim is to show you the this okay, I'll do it in the three phase. Huh? I'll do it in the three phase. Let me open my three phase circuit. Just give me a second because I wish to give you more and more information so that you guys do it at your and just give me a second. Hmm, three phase converter. Let me take the three phase converter. and I am directly taking the full wave converter. I am directly taking the full wave converter. Kindly excuse me and pardon me for this because the constraint of time. I have only 9 minutes left, and I have to cover a lot of things. That is why I am little bit hurry. See, here are six devices are there, and load is there, and three supplies RYB all are 120-degree phase shifted. You can directly take it from the three-phase supply as well. I'll just show you. There is three-phase supply is also available because I want to do some analysis. That is why I have taken like this. Here you can see that three-phase source is available. I made this three-phase source using three single phase, and they are 120-degree apart. Here you can see phase degree is 2 pi by 3, and here it is minus 2 pi by 3, right? So all three phases are 120-degree apart. And to generate the control pulses for this, I have using the cosine firing scheme. Can anybody tell from the power electronics or electrical background? Because this the workshop is for only for electrical engineers, so I believe all are from electrical, whether you are from the control system, power system, or machine drive domain or power electronics domain. But this is very fundamental. I can expect the answer from any one of you. That is why I have selected this cosine firing scheme. Why people or industry select this cosine firing scheme? Can anybody tell?
Sir, I think you are using thyristor. That's why you are using.
No, no, no. See, for supply, see, frequency is only 50 hertz, and for lower frequency and higher power rating, that thyristor has to be used. There is no use of using this MOSFET and IGBT. All are voltage control devices. But
Sir,
you
in
require the current
thyristor,
control.
in thyristor, it is mentioned.
No.
No, there are many types of firing scheme. Cosine firing scheme is one of them. So,
But
if
why
it
it is
is
why it is always acceptable to use cosine firing scheme? The reason is, what would be the output voltage? 3 Vm upon pi cos of alpha means output voltage is proportional to cosine of firing angle, isn't it? 3 Vm upon pi is the constant term. 3 Vm upon pi is the constant term. The only variable is alpha. So output voltage of three phase is proportional to this. Is this type of question is in fact asked in GATE and ES. Engineering services exam. So many faculties are in this FDP. So I suggest keep to teach your student keeping the mind of keeping mind their vision, their mission for GATE and ES. You keep on searching the question asked in GATE, ES, IS, and teach them accordingly. Right? This is our moral duty. So come to the point, that is, since the output voltage is proportional to cosine of firing angle, that is why we have selected cosine firing scheme. And for that, what we did, it is very simple logic. Very simple logic I have made. What I did, I take 3 voltage as a reference, reduce it by 1 by 23 gain, because the input supply is 230. We divide by 23. So it would become that 10 volt, just to show the analogy between hardware and software. Control voltage is order of 5 to 12 volts. So I have selected control voltage is 10. The maximum voltage is 10. Now what I did, after taking this, I have given the for 135, I have taken one. One side of the wave, and for 462 lower device, I have inverted those waves that you can see here. Now after that, what we did, we provide the delay of 90 degree. We provide the delay of 90 degree so that the sine is converted into cosine, so that the sine is converted into cosine if we give the delay to them, right? This is the philosophy. And then it is being ending with the zero crossing and given to the particular thyristor, and these blocks are used just to provide the one sample delay so that there should not be any loop. When you start designing the control na, you will get these are very very elementary and simple thing. So it is of no use to discuss all this. Now run the simulation and see the waveform. The waveform is like this. The waveform is like this. Is it fine?
Yes, sir. But sir,
Is
in
it?
this waveform, you can see there is a very minor negative. I think that due to inductor, there is a very
Ah,
small
yes, you
angle.
are absolutely right. You are absolutely right. I'll do the zoom and you will see the value of current is not zero. That is why. Look at this. The value of current is not zero. That is why it is negative.
Yes.
Right? So that principle which we learn in the single phase supply, that is the same thing is applicable here. It is. The same thing is applicable here. It is. Now take the look on the FFT. Just check me whether okay, this is the supply voltage. So I hope no, this is the output voltage. This is the output voltage. Let us take this at 0.05 and number of cycle is 6 and frequency is 50. Frequency is 50. Make it same as maximum frequency, harmonic order, and then display. Here you can see the output voltage. It must be DC. It must be DC, right? And the
Sir, sir, sorry
yes,
to disturb you. There is a main screen. You have taken a TSD block. So that block and
uh,
this one is different or same?
no, that will give you the value of TSD. Total harmonic distortion is 0.1794
Agree.
in the source current. In the source
Hmm.
current, right?
Yes.
This
The
you
same
can
thing
take it
is
from
in
the
except, huh?
in no. This TSD is the total value of the TSD. It is not showing the various component. Third, fifth, seventh. It is not telling which component is having how much value. But if you look at this FFT analysis, it will tell you the value of various component. Look at this. I should do it again for you. Just give me a second. Uh, 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 50. Although I am doing it for the output voltage, which is, I mean, not worthy because output voltage is DC. See, this type of second component is this much, fourth, fifth, and all. And you can have the list view as well. It will tell you the value. Here
Hmm.
you can see, right? It
Okay.
will tell you the value.
Okay. This
50
block and
is
this is different. Both are different things.
different. That will tell the total harmonic distortion means the all components are added, right?
Fine.
All components are added. I'll stop here because the time is sharp 1:30 and we will start again at 1:40 and I'll expect that coordinator some Ronak or Dhruvi take the charge and share the feedback link and all.
Yes, sir. All of you are requested to kindly fill out the
Uh,
feedback form.
Ronak,
I'm
turn
sharing.
on your camera as well because people should know who is the co-coordinator of this event. Right, Bacha? Good.
Yes, sir. Sir, I'm sharing the feedback from the chat section. Everyone is requested to fill out this form.
rectifier related things. Now we will see the chopper circuit and all. Then we will see some multi-level inverter rather than simple inverter. We will directly see the multi-level inverter and all. Let me close my all previous window. Just give me a second. Just give me a second. Let me close my MATLAB. Udit and Kushal, you just keep on
Yes, sir.
admitting the participant. Let me share my screen. I hope my screen is visible to everyone.
Yes, sir, it is.
Fine, fine, fine. Hmm. Okay, just give me a second. Now we will see the some chopper circuit. Chopper is the device which is used to get variable DC from fixed DC voltage. Right? Very simple buck chopper is there. Very simple buck chopper is there. Now we will see the operation of this buck chopper. And I advise to Udit and Kushag, be so attentive that people keep on joining. They will do the thing as per their own choice. And I can understand it is very difficult to manage such a huge participant at a time. Right? We have 386 registrations. Sometimes someone comes, sometimes others come. So this type of things keep on going on. So you just both of you please manage. Now come to the point that can anybody tell why we are not using thyristor here? Why we are not using thyristor here?
Supply DC, supply is DC, so conduction is not possible automatically. So we require external turn-off circuit for SCR.
Yes, yes, that is the point. Since the supply is DC, the thyristor will come in the forward eyes the moment it connected to the supply. And when you wish to turn off, you have to have used the force commutation circuit. It is of no use. Moreover, the chopper circuit or the inverter circuit, we use PWM, right? So there the switching frequency is quite high. So for that reason, because that is having their limitation, it is operated at low frequency. We have to use the some voltage control device, right? This MOSFET or IGBTs are being used. The moment you withdraw the pulse, it is get turned off. That is why we are using this. So MOSFET and this diode. First, let me remove this. So the circuit is very simple. The DC supply is there and the MOSFET is there. We have given this pulse to the MOSFET and the switching frequency is, I think, it's very low. It's very low. Let us make it, because sometime I was teaching to some students. That is why I have taken this. Now switching frequency is 1 kilohertz and for 50% it is turned on and 50% it is turned off. Now run this simulation. When you run this simulation, you will find for 1 millisecond, for the cycle of 1 millisecond, half of the cycle it will on, and for remaining half cycle it will off. So output voltage would be having positive zero like thing. Let me show you. Here you can see. Here you can see. This waveform is clear. This waveform is clear to everyone. The output voltage is starting from 0 and reaching to 100 volt, right? It is little bit less to 100. The reason is in the path there is a MOSFET and there is a voltage drop, forward conduction drop of order of 1 to 2 volt. That is the drop here, right? And then it is 0. Whenever MOSFET is on, thyristor is flowing and the value, yes, and the value of the current
Sir,
is 10 ampere. Yes, please.
sir, your screen is not visible, sir. It's only your face is coming, but nothing is visible.
No, no, it is visible to us.
Uh,
Visible, sir, but screen is moving slowly.
Okay, might be
okay.
just my end.
It is visible.
Other participant, please tell. Otherwise, it is now no use of watching my face.
Visible. It is visible,
Okay,
sir.
fine,
It's
fine,
visible,
fine.
sir. Visible.
Oh, great. So, is it like that? Ki some person, my screen is visible. Some person are having only my face, or both of the thing is visible on the screen, my face as well as the screen.
Both are available, sir.
Okay, from my
So
end, my
both are
screen.
available.
Okay, fine. From my side, only my screen is there. So I'm not able to watch any participant or anything else. So Kusharag and Udit and the rest participant, please take care of all this thing. The moment any screen, MATLAB screen is not visible, please let me know so that we can reconnect. Okay, now you can see the value of current is 10 ampere. Why it is so? The reason is we have selected the DC supply of 100 volt and the value of resistance is 10. Just see. So 100 divided by 10, it is absolutely fine. It is absolutely fine. Now I'll make this load RL type. Let us make this load RL type and take the value of inductor as 10 millihenry. Now I run the simulation. Okay, now I will ask again one question. आप कहोगे sir, you are asking so many questions. You are not teaching anything. You keep on asking. But that question will give you more than what I can teach. Right? So just tell me what would be the output voltage. Can anybody tell what will be the output voltage? I think now my voice is also not coming.
We can hear you.
Can anyone tell what would be the expected output voltage? If you tell me the expected, then I'll open this scope and tell you what is going to come. Anyone of you just tell me what would be the output voltage? I have only changes this load. Nothing else is
Output
changed.
output is DC,
Yes.
but value is somewhat either it is box chopper, so it is decreases. Value is voltage value.
See, listen, Victor, listen. In the previous case, what you were getting? You were getting output only for the 50% of the duty cycle and the output value is 100. It is the buck chopper. How we calculate the output? Output voltage is calculated as V output is alpha times VDC, where alpha is T on divided by total time period. So 50% duty cycle means it is half. So average output voltage is only the 50%. I am asking what is expected output voltage waveform. Means still it will be like that. For 50% it is on and for remaining 50% it is off, or for the whole time period the cycle is running. Just see how the voltage is coming. Can you see the value of this current? What is the value of this current? Red. See, if you keep on answering my question, the value is written here. Is it visible? 0.5 into 10 to the power 5. Is it visible?
Yes,
Not
sir.
visible. Another thing, can you see the output voltage? What is the value of output voltage? Let me make it zoom. Can you see the output voltage? How much it is coming? Array, output voltage is zero. Output voltage is zero. This negative sign, can you see? Can you see this negative sign? Y-axis. So where is Aparna ji? Aparna, in this, are you available in this meeting?
Yes, yes, sir. Sir, this is Amrita, not Aparna.
Amrita, sorry. My mistake, apology. So,
Chalo.
Arpita, now you can see the output voltage at your end or
Yes,
not?
sir. It is zero.
It is zero. Why it is
Hmm.
so? Why it is so?
Sorry, sir. Actually, I have not seen the circuit diagram. Okay, I think the
Now
diode
you
is
can
not
see.
connected.
So, diode is not. You just try to understand the physics. Physics of inductor, physics of resistor, physics of capacitor. I used to say my student, your basic electrical engineering, if it these three components R, L, C, if it is clear, people say that electrical engineering is the toughest branch. But what I believe, if the fundamental related to R, L, C are clear, then I mean there is no point that you will not secure 75% in your electrical engineering degree. See what happened. You have not connected the diode. Absolutely fine. The very
Hmm.
first time it will get turned on, your inductor gets charged, and after 50% of the duty cycle, this device get turned off. Now, what is the tendency of electrical? At that time, the current was at its maximum value. Inductor will develop a polarity in such a way Inductor will develop polarity in such a way that current should keep on flowing in this way. Current should keep on flowing in this way. So, what it will do? It will develop polarity in such a way this device will never come in the forward bias because this voltage is more than 100 voltage. Even if you supply it, it will not going to turn off, right? And there is no path of discharging this energy. So what happened? Inductor will keep on charge. Sometime you might notice in your ceiling fan, even if you turn off the supply and remove the capacitor and touch these two terminals, there is a spark. So your inductor will get charged in this case. So what you have to do, for RL type load, RLE type load, you must connect a freewheeling diode. Now, when this device is off, the current is flowing through this. The current is flowing through this. Just run the simulation once again, and you will find for 50% of the cycle, for 50% of the cycle, the output voltage would be there, and for remaining 50%, there is no uh, voltage. Just see. Let me put it here. Just see. Just see. You can. Mhm. Just give me a second. Look at this. When this device is on, current start increasing. At this point, you turn off the device. When you turn off, current goes down. You just don't get worried about this thing. Sir, why this zigzag voltage is coming? It is coming because of snooper. You can see the variation of current. The same variation you will find here. Look at this variation in current. And we can remove this type of thing using the proper selection of snooper. proper selection of snooper.
Sir, but the distortion will be minimized, can be minimized by the help of this Navar capacitance?
Snooper, only snooper is the reason. That
Okay.
see, this zigzag is coming now. It is only
Hmm.
because of snooper. This is only because of snooper. Right? During
Okay, sir.
this period, just just change this value. Make it 5,000. Just see. Just
Okay,
see
sir. Need
how
to.
beautiful it is.
Oh, it's very nice.
How beautiful it is.
Beautifully, it represent waveform. Sir, it is
See,
required to reduce the resistance value.
no, what I did, I just increase the resistance. Just see, from 500 to
Increase the
make it 5,000.
resistance.
See, I don't get involved in the snooper circuit design. Otherwise,
Hmm.
I'll take 2 or 3 hours only on this. How to design a snooper circuit.
Uh,
Actually, I have taken this value so high. Now what will happen? Your circuit time also get increased. RC value get increased na bhai.
hmm.
RC value get increased. At the same time, snooper losses also increase. I square R losses. So you have to do
Sir,
compromise with. Huh?
is it practically possible?
Yes. Practically, I teach to my student during my 6 semester course. What we do, we take the resistance in two component. Means R1 plus R2, we will make it 5,000, let us say, and the
Hmm.
R1 is somewhere around 4,500, 4,900, and R2 is only 100, and we put the diode across that higher value of resistance so that it will bypass during the charging time. RC time is reduced and discharge through this. The value of R is controlled by the limiting current of this snowbar, this diode, right? So that
Hmm.
aspect, we will discuss it in some other FDP or workshop. Now here the point which I wish to show you, that by proper selection of snowbar circuit, we can we can eliminate the transient. Now again I'll make 500 and you can see again those things will start to come. Just see, all zigzag is coming, right? The moment I make simple this snowbar circuit 100 times, 100 times, just see it change totally. Another important thing, let me remove this weapon. Can apart from Arpita, can anyone tell what would be the output voltage when your thyristor, when your MOSFET is off? What would be the output voltage? Very important aspect.
Zero.
Can anyone tell? अनिकेत बता रहे थे, अनिकेत भी बताते हैं, बाकी लोग तो आई मीन they know, but they don't want to share their knowledge with me. I know everyone knows all this thing, but they don't want to tell me. Yes, what would be the output voltage? Can anyone tell when the MOSFET is off? Yes, please.
Sir, zero.
Can anyone tell? Yes, please. Huh?
Sir, zero.
Yes, your voice is very low. Someone is trying to speak.
Sir,
Okay,
zero.
Arpita, can you guess what would be the output voltage when MOSFET is off?
Sorry, sir.
What would be the output voltage? This is the output voltage. What would be the output voltage when this MOSFET is off in this circuit? आउटपुट वोल्टेज
Sir,
क्या होगा
somehow
अगर
sir, zero might be because the MOSFET is absent na, so how to connect the circuit if it is an open circuit?
ओके ओके
Be- because
तो
inductor will not
आउटपुट
be charged.
वोल्टेज अच्छा ओके लेट मी ओपन दिस कैन यू नाउ टेल व्हाट वुड बी द आउटपुट वोल्टेज
Sorry, sir.
can you now tell after seeing this what would be the output voltage when MOSFET is off?
Sir, okay, MOSFET is off
Sir,
and diode is on,
0.8.
na?
Ah, yes, who is saying? Another person.
Sir, 0.8 volt.
You are saying 0.8. Partly correct. 50% correct.
Minus 0.8.
Anyone else? Kushag Chaube and Udit. These are my third year students. Yes, it would be minus zero point 0.8. Very fundamental thing. I used to say my student, whenever any device conduct, there is a forward voltage drop. Anode minus cathode voltage. That means from here to here, voltage drop is 0.8. And the output voltage is what? It is from this side to this side. This minus this. देखिए, look at this. Plus minus. This minus this. If this voltage is from here to here 0.8 and it is connected to parallel of it, then output voltage is minus 0.8. Now check the waveform. I'll show you. Check the waveform. Just see. If you understand the thing at this level, then only the beauty of MATLAB you can enjoy. Just see, it is 0.8 volt. It is 0.8. Right? Don't get confused, sir. This slightly taper type things are coming. It is because of snoober and all. But we can say it is 0.8. Just see, the ripple is 0.80065 to 0.865 to 0.804 means 0.003. 0.003. That means nothing. That means nothing. Right? So we can say the output voltage when the device is the MOSFET is off, it is 0.8 negative. 0.8 negative. And the current is going like this. Current is going like this. Okay. One more aspect I would like to discuss with you. If I make this inductor 100 times lower, what you expect, what the changes you expect at the output is there. What are the changes you expect at the output? Yes, please. अगर इंडक्टर की वैल्यू, if I reduce the value of inductor 100 times, what changes you expect at the output? The changes will be current would be decay very soon and it will be converted from continuous to discontinuous mode of conduction. Look at this. It is decay very soon and it is now discontinuous mode of conduction because during this period there is no current. There is no current. So this type of thing you should teach your student. Now there is a boost chopper. Let me open this. Okay. Okay. Just let me check. This is very wonderful chopper. It can boost the voltage, it can buck the voltage. For 50% duty cycle, it will do this. And if the duty cycle is more than that, then it will do this. And how it operates, there is a DC supply, then switch, and then we have inductor. This is the boost inductor. And then again we have switch. Whenever these two switches are on, this inductor gets charged. And when the switch is open, supply voltage plus inductor voltage will come at this stage. Right? It will come at this stage. When you wish to operate it as a buck mode, what you have to do, you always keep this switch off. You always keep this switch off and operate it as on off mode. So the voltage will be buck mode, or chopper will operate in the buck mode. So in that way it is operated as buck as well as boost mode. And the switching pulses and all are generated like this. It is the error signals circuit. So you can see it looks very simple, but inside the control block there is so many things involved. Inside the control blocks there are so many things involved that you should keep in mind. Whenever you design any simulation circuit, try to make it very neat and clean so that you should not get confused. Right? Now, just see the logic behind this, and these logics are very, very simple. Right? It is not very tough. Right? It is not very tough. What you have to do, you just operate when this converter has to operate in buck mode and when it is operate in the boost mode. And one thing I would also like to tell you that there is no standard format for doing this simulation. It is only my logic. I have developed it according to my understanding. You can develop your own logic, right? So there is no point of discussing how to. Acha, one thing I should like to discuss from where this OR block I have taken AND block. If you remember yesterday classes, I have already told you. Can anyone tell? This will also some short of your test. Can anyone tell? Yes, we have 112 participant. Anyone tell me? Yes, please. This I have taken from the logical operator. Simulink log logical operator. Go to here and take it from, just see where is logic and bit here. All logical operator are here. You can add it. Let me add and make it whatever you wish. And or nor, XOR or anything. Right? So you should keep on practicing, then you will understand the things. Now come to the point. Just see the output voltage. Just see the output voltage. Just see the output voltage is 49.2. What I required 50 volt. At present, I required 50 volt and it is giving absolutely fine. Absolutely fine 50 volt. Right? So, depending upon the logic, it will operate. Clear? If you wish to change this, if you wish to change this, let me show you one more thing. It is 50 volt. Output, output is, input is 50 volt, output is 49.23. Right? Now, just make this DC voltage, make this DC voltage 100. Just see, just see. It is, it is approaching towards 90. Where is? Just give me a second. Just see. it is 100, it is 100, it is 99.23. Whatsoever the input voltage, output voltage is trying to achieve at that level. The logic is something like this. The logic is something like this. So that type of thing you can make. Now one more topic related to this I would like to discuss, that is your three phase inverter and the single phase. When we will talk about the three phase, I will try to discuss that multi-level inverter. Huh? Let me take this inverter. Let me take this inverter. Let me run the simulation. You can see, let me remove the limit. If you remember the three phase voltage waveform, how it should be? It is VDC by 3 to VDC by 3. Those who are working in the field of power electronics, they know this thing. And the line voltage is VDC minus VDC, plus 100 minus 100. And the phase voltage is VDC by 3 to VDC by 3, then minus VDC by 3 and minus 2 VDC by 3. I hope, if apart from Udit and Kushal, third year students have joined. There are very few, I know. They have just gone through all this simulation and the thing. Remember, the waveforms are like this. How we make this circuit? And I am very surprised that no one is having any doubt. Sir, how you implemented this simulation which you are showing to us? Because see, if I provide only the solution without knowing the question, then it is of no use. I'll happy if you ask, because the previous session was very interesting. Arpita give a lot of question. That was very good thing. I expect same type of thing from other participant as well. So any participant, just unmute yourself and ask if you have any doubt. Yes. No doubt. Arpita,
Sir,
do you
is
have any
it,
doubt? Yes, please.
sir, I am asking you is it a two-level inverter? Actually, the title was missing. That's why I could not understand okay, whether it is an inverter.
Look at this at the top.
Okay.
Two level
Sir,
inverter, two level, three phase.
So have you taken the PWM? I think sinusoidal PWM has taken phase opposition.
Only sinusoidal. I mean only sinusoidal PWM. You can see the logic. That is why I am asking. If the student asks, participant asks. I know there are so many faculty and persons from industry. For them, it is a very elementary thing. Might be possible, but if PhD research scholars are there, BTech students are there, then you should ask the question. You can see here, this is the universal bridge. From where you will get this universal bridge and what it does, can be used as a rectifier, or when we can use it as an inverter, can be used as a single phase, can be used as a three phase. There are so many questions could be asked. I'll show you.
Sir,
look at this.
Sir, can I ask one more question? As I am working on the MLI, so when we go for the phase opposition type PWM, okay, so we have to give the repeating sequence, because each and every phase we have to change the triangular.
See, Amrita, I'll
Yes,
come
sir.
to that point. You wish see there are level shifting, there are phase opposition, deposition, there are several type of techniques which are being used. I'll demonstrate
Hmm.
those techniques as well. Right?
Okay, sir. At your end, just give me one brief idea about the different types of PWM technique in multi-level inverter or
I
inverter, so that we can
I
implement as a research.
I'll show you. See, this is the simple unipolar or bipolar for two level. But I have still up to you can say 50 minutes I left. Right? So
Okay,
I'll
okay, sir.
cover that
You please
topic
carry on.
also. I will also try to
Okay,
give
okay.
you easy. Why I am asking that? See, these things are you should know. These are अरे भाई admit नहीं करते. ये look at
Actually, I
this.
know about this inverter, but the design you have prepared, it somehow because I took as a subsystem as a PWM. Okay, you
No,
just place
no.
everything in
See,
one page.
Arpita. Actually, what I experience, don't use MATLAB PWM block and all, because in that case you
Okay,
don't have any control. In that case, you don't have any control. Whenever you do research, start with scratch. You develop your own control logic so that you can control at any point of time. Right? You look at this.
okay.
Very simple control I have used. Very simple control. You will never find this why I have used this memory block. No Google or Chat GPT will tell you these things. It comes only by experience. Whenever we do this type of non-linear simulation and all, there are sometimes simulation throws error. There is zero error, NaN error. Why this throws?
Sir,
Because yes, please, somebody is asking
sir,
something.
sir, sir,
Yes.
one more thing. Because when I designed the sinusoidal pulse width modulation technique, I usually take the like this as a sin omega t minus 120 and sin omega t plus 120. Like this I designed. Okay.
Yes.
On that basis, just greater than equal to then logic gates,
Fine,
then I'm
fine.
just getting the output. But here
Yes.
you are using the memory blocks. So what is the reason behind this?
That is what I am telling you. Sometime it happened that your simulation get stuck. It shows error, right? And says that it is in loop or NaN value. For that things, what you have to do, you just put one memory block. This memory block will provide a delay of one sample time, right? So the data what it was asking that is hold for a one period. So there that loop is break and your simulation run, right? That is why I have used this block. It is not necessarily I mean in your version it is required, right? But sometime it
Okay,
happens
sir.
when you do the modeling. For example, my work is on open and winding induction motor drive. Open and winding is not available in the MATLAB. You have to made it in the Simulink block equation writing and dot and filing and everything, and that has to be converted into that real time simulator mode and all. So there you should use all this thing, right? In any complex type of network. So you can see this is very simple as I have used the repeating sequence of 1 kilohertz and it is simultaneously compared with the sinusoidal wave whenever this is higher 135 are trigger and inverter of this are going to 462. 462. So all six devices are getting oh shit बंद हो गया क्या no so बंद हो गया fine no issue बंद हो गया तो हो जाने दो so all six devices are being triggered and your output is coming. Now come to the multi-level inverter. Now come to the multi-level inverter. See, multi-level inverter, why we go for multi-level inverter? Since Arpita, you are working on this, I'll ask a simple question. Why we use multi-level inverter?
Because two-level inverter has the high switching losses and high, I think, electromagnetic interference like this. So sentences are read about from the literature. So that's why we have
Okay.
to move towards the multi-level.
See, the first thing is what we want as inverter output. Forget about the two-level or multi-level or any level. What is expected at the output? Just tell me.
Pure sinusoidal waveform?
Yes, we required pure sinusoidal waveform. Is it possible to have pure sinusoidal waveform?
Sir, is it possible to?
Pure sinusoidal waveform
No,
using
no,
multi-level
because
inverter?
no.
No,
Multi-level
it is
inverter
not
provide the
possible.
staircase waveform.
Exactly. To get the sinusoidal, we should use the infinite number of levels. Then only we can have the sinusoidal waveform. So multi-level inverter gives you staircase waveform, and it is possible to have improved quality waveform with fundamental switching frequency. So switching losses also reduce, dV by dt also reduce, in interference also reduce. These are the inherent quality of multi-level inverter. Because of this reason, people use this multi-level inverter. Now let us start. See, this is our three-phase supply. This is our all three-phase diode clamp inverter, and I'll show you the output voltage and all. Oh, let me give the sample time 50 to the power, because sometime it happen to tell the student we do changes, and if changes save wrongly, then simulations start giving error. Okay,
Sir, need to
fortunately.
require the change the solver?
No, actually, see what happened now when I teach taking some lecture just to demonstrate something, I changes something, and unfortunately that simulation is saved. So that is why it is saying like, for example, in this case, that sample time was not defined. So I just given, you just see, look at this. What I did, I just defined that sample time TS. It is 50
Hmm.
microseconds. Right, I have deleted just to demonstrate some student. So
Okay.
now you can see, this is all measurement block. You can see the various parameters, and if you look at the output voltage, let me show you here. This, just give me a second. Look at this. This is the current of, actually this is with filter. This is my PhD student work. And the
Sir, it
filter
is
and all
a
those things are
multi-level inverter?
involved. Yes. It is simple three-level inverter. It is
Okay.
simple three-level inverter. Right? It is simple three-level inverter. It is simple three-level inverter.
So it looking very
All,
complex.
all. Look at this now. This is three-level inverter. You are working in the field of.
Ah,
You can see this is the diode clamp three-level inverter.
it's a
That's
direct
it.
clamp. Agree.
Right? It's very simple. See, whenever we do research, we have to start from beginning. Like first, we have to check the quality of conventional converter, like 3 level, 5 level, CHB base, diode clamp, and cascade edge bridge. Then we will provide some new topology. Likewise, we also did all this simulation just to check the conventional converters. Right? After that, we go for this. Let me open this. Let me open this. Mhm. Actually, these are very complex simulation. But
Sir, what
any
type of PWM is used here?
simple here, third harmonic. See, it is very difficult to get the space vector modulation, because in that case you have to know the circuit that sector identification. Then you have to know the triangle in which it comes. So up to 3 level space vector modulation is fine. But when you go for higher level like 9 level, 11 level, 13 level, then it is very difficult. So we have invented, we have taken one technique which was proposed by Professor K. Kumar of ISC Bangalore. In this, what he did, simple sinusoidal waveform, and one offset is given to this sinusoidal waveform. And what is the value of that offset? It is VA plus maximum of VA plus VB plus VC plus minimum of VA VB VC divided by 2 with negative sign. Means the three phase voltage में, three phase reference voltage में at particular instant VA plus VB plus VC का जो भी maximum value आए, that you should take, and it should be subtracted from this minimum value, and take the average of these two quantities. If you take that, then it will give you exactly is 99% the similar waveform which you obtained through the space vector modulation, no matter how much level you are using. No matter how much level you are using. Right? So I'll tell you, actually in this, 4 control schemes are used. You can see control scheme 1. Let me little bit make bigger size. You can see this is control scheme 1, this is control scheme 2, this is control scheme 3, and this is used scheme. That means the scheme proposed by us, right?
Sir, what are the 4 control schemes?
I'll I'll show you. I'll show you. Right? This inverter, first let us have a look on this inverter. This inverter is very special type of inverter which was designed for induction motor drive. Right? What is the speciality of this inverter? Generally what we do, we have 3-phase supply and 3 terminal of the motors are accessible to you. You just connect your inverter to with this motor and run the motor. What we did, we connected to 2-level inverter. Look at this. It is simple, you can see. It is simple.
Yes, sir.
2-level inverter, isn't it? Look at this.
Yes, sir.
Simple 2-level
So I
inverter.
think in your design, I think it is little bit complex as compared to my design, but somehow it is understandable.
No. It is very simple. It is very simple. People think that it is very... See, we have received 2 transactions on this. IEEE Power Electronics and IEEE Industrial Engineering पे जो है. But it is very simple. Very simple. No complexity in this. What you have to do, you have one induction motor. The neutral of induction motor has to be open. If you open the neutral of induction motor, you will have the 6 terminal, isn't it? If you open the neutral of induction motor, you will have the 6 terminal of the stator.
Yes.
And feed that motor with 2 inverter. Simple 2-level inverter. This is also 2-level. This is also
Yes.
2-level. And these terminal are A1, B1, C1, A2, B2, C2. Right? And this is the modeling of this. It is a little bit complicated. If I explore this, आधे तो हमारे student कहेंगे, oh my god, what is this? It is totally on basis of and this expression, function block, S block I have used. Look at this. All these are the equation written in the function. From where you get this
How is
function?
it possible? Sorry to interrupt you. How is it possible? How to write this equation in this function block? Actually, I
Look at
tried,
this.
but I was unable.
Yesterday, have you seen my lecture?
No, no, sir. Yesterday I was missed the second half class because I
That
have
is
no idea.
that is the problem. That is the problem, right?
Hmm.
You you can use your subsystem as well as function block. Everything you can use, right? There is a this. Let me show you. Let me show you.
But
Just user defined function. Here it is. Look at this. You can write your own as function. You can write your function here. Just add to final result. Here you can write your function where it is. You just check. Here it is. You just write your function here. What's the problem? You just
okay,
write any equation you can write here. It will take two input u1 and u2 and u2. The port is only one. What you have to do, you have to use the mux. You just give those signal to mux and connect here. You will get the output depending upon the expression which you have written inside this. The same thing I applied here. That is what I am saying. I don't know how to operate my MATLAB here. Even though since last 20 years I am using MATLAB, but I don't know how to use it. You just keep on learning. You just give time. You just invest your time with MATLAB. It will give you a lot. Look at this. The same function block I have used. The same function block.
hmm.
U2, U1, U3. There are three signals. Look at this. U1, U2, U3. Mux से जा रहे हैं इसमें. Using mux, these are giving and it is giving to the output and then integrator. And these are the machine modeling. Simple induction motor machine modeling. If you are working in the field of drive, you can contact me. I'll tell you the books, resources, and everything I'll provide. Right? No need to worry.
Sure, sir. Actually, I have lots of doubt after your this workshop.
Oh, that means I am creating confusion.
Somehow, because the diagrams are very complex. What I am thinking and what you have
Please,
designed, so
um,
it's very difficult.
Amrita, listen. Have you ever read any transaction paper? Any transaction
No,
paper of
sir.
any?
I have SCI paper because the problem is I have
Listen,
completed my PhD material
listen,
science.
listen. Even though it is in the material science, see, whenever you read any research paper, it looks very complicated. But when you ask to that person who published that research, he says that it is very simple. The reason is research paper or the transaction paper, it is the outcome of someone effort of continuous doing the study in 2 or 3 years. It required time and patience, right? Then you understand this complex, which you feel that it is very complex. I do agree it is very complex, but it is not built in a single day. You think, then you write the equation on paper, then you develop on the MATLAB, you check the result. Is it expected as per expected result? No. You again do the calculation, again do this, then only these things are coming. It is simple. I have written the equation using the simple function block.
Okay,
It is
sir.
the equation, only the simple block. DQ to ABC transformation, then speed and everything I have calculated. Look at this. These are the simple
So,
equations.
sir, I did
Yes.
the ABC tissue transformation, but it is a proper using blocks. I have not never used the equation format. So that is a problem
It is
because
what is I am telling you. See, you have used whether it is in the control or somewhere. You simply take the block from the Simulink block. You cannot
hmm,
have the control on each and everything, because when we did this thing, open and winding induction motor was not available. Now if you check the MATLAB version 21 onwards, or now 25th 25 release, they have incorporated this open and winding induction motor in the graph itself. But now I am working on the one of my research scholar. He might join this workshop, Astos, he is working on the 5-phase induction motor. There is a phase difference of 72 degree.
Yes,
Now,
yes.
if you look at the MATLAB, there is no possibility of having this type of block. Then what you will do? He is writing
Completely
that
no.
all calculation based on this. I have given all this simulation to him, and he is developing equation based on this. Everything is
Okay.
same, only the phase difference is 120 degree. And
Mm-hmm.
there are 3 phases are different type and 2 phases are different type. So those type of thing, when you do something new, then you have to have your own model, your own equation. It is not possible using nowadays. I'm not saying don't use AI and all. Use
Yes, sir.
AI
In
or everything
AI,
whatever you
it's
find.
not trustable. Mhm.
Yes,
Nothing's okay.
exactly. You will
After,
garbage as well as good in the
yes,
AI.
sir.
You should know what is
Ex-
good and what is garbage. Sometimes student come and they write mail to me कि sir I hope you are doing well. I used to think अरे यार रात में तो मिलके गया, why he is not believing that I am doing well, why he is hoping that I am doing well, because he take that email from chat GPT और उसकी पहली लाइन
yes,
ही
yes.
यही होती है आई होप यू आर डूइंग वेल, और स्टूडेंट वही चिपका देता है सर को, बड़े बड़े फैकल्टी को लिख देता है और प्रोफेसर करके लिख देता है, सर तक लिखना भूल जाता है, क्योंकि उसका दोष नहीं है, वो बेचारा चैट जीपीटी पे आश्रित है, चैट जीपीटी ने जो बताया वो लिख दिया, बट रिसर्च कैन नॉट बी डन ऑन द बेसिस ऑफ चैट जीपीटी, राइट? So you have to have used
Yes.
this. Now come to this, the main thing which you were asking, that how to generate different type of control strategy. And now this model is working on the this constant V by F control. Constant V by F control. Why we use this constant V by F control? We use constant V by F control because the flux is constant. If we keep the flux constant, we wish to keep the flux constant, then we have to have the ratio of voltage and frequency same. The ratio of voltage and frequency same. भाई ये पंकज यादव जी शायद अपने ही स्टूडेंट है, इनको ऐड करो भाई, देखो जरा, अदरवाइज मैं ही ऐड कर दूंगा, उदित और ये तुम लोग क्या कर रहे हो यार, मेरे सामने ऐड होने का आता है तो बहुत खराब लगता है. खैर, so it has to be operate on V by F basis. So what I did, I have taken V from here, and the speed speed if we know, then this from voltage and frequency, speed we know, we can have the frequency 120 f upon p. The number of poles are fixed, frequency is fixed. So this I think you have used, Arpita, these 3 waveform you have used, v sine 2 pi
Yes, sir.
ft, v sine 2 pi, right?
Yes, yes. Yes.
Whatever you are doing, I am doing the same thing with slight modification. Now what I did here, I have used this offset. I have used this offset. What it is? It is addition of third harmonic, 20% of third harmonic. Normal sine wave and 20% of third harmonic needs to be added in this as a reference signal. So you can notice,
Sir,
let
why?
me make, I'll tell you, control Z. Just 20% of third harmonic needs to be added. This is the control strategy, right? Available in the research. When you introduce third harmonic in the reference wave, it give you better response. See, sinusoidal response, you cannot go up to modulation index 1, because when you go modulation index 1 na, it will convert into this over modulation range, if you remember, right?
Sir, is it
So
selective harmonic elimination technique?
no, this is not the selective harmonic elimination. It is simple trying to achieve space vector modulation using sine. In that
Okay.
phase, it is one of the technique. You should inject 20% of the third harmonic. So you can notice Rather than taking 2 pi f, I have taken 6 pi f. Means 3 omega
Mm-hmm.
t. Right? So
Okay.
that I have taken. Now, this is one strategy. So these three waves are generated. These three waves are generated, and after generation of this, it is being compared by the triangular. This C is the triangular, and where these C are there, this is the repeating sequence. This is the repeating sequence I have taken, and these repeating sequence are the level shifted. So once let me run this simulation so that things would become more and more clear. Look at this. Jaiswal Saab, Sabaya Jaiswal, please turn off your mic. Otherwise, organizer will remove you. Because when I am asking any question, your mic is not getting turned on. Now it is on. Now look at this. Look at this. Arpita, these are the three waveform. These are the three waveform you can see. It is the third harmonic injected waveform. These are the three reference signal VA, VB, VC. And as it is the three level inverter, it is the three level inverter. So you know the n level inverter required n minus 1 triangular. N level inverter required n minus 1 triangular. So two triangular are required, two triangle are required. So these two triangle, all three waveforms are simultaneously compared with these triangular and the pulses are generated. Right?
Sir,
All
I
the,
think वो
yes.
20% harmonics will create the somehow it is one type of sinusoidal. Otherwise, if I taking normal three level inverter, it is looking like one type of staircase sinusoidal. Am I
No,
correct?
no. Listen, Are, you got confused. You got confused. I have not shown you the output voltage. I have shown you
Okay,
only
okay.
the reference signal. It is the reference signal.
Okay, okay, fine. Sorry, मुझे लगा कि it's an
No,
output
no, no,
waveform.
not at all. Not at all, dear. This is the reference signal, only control strategy, right? Although I have taken it at the means a higher level, 600 volt, 300 volt, but if we are going to implement in the hardware, it has to be reduced at the proper scale. 12 volt से ज़्यादा नहीं होगी. Clear? But these are the
Hmm.
reference signal only. These are the reference signal only. I have not shown the output voltage. If you wish to show the output voltage, I'll show you. This is the output voltage. Look at this. This
Then
is the
it's fine.
this is the output voltage, right?
Yes, sir.
So so now this is the one strategy. Now let us have another strategy, and also I'll show you one thing. Make it INF, right? And let us make this. Let me open the voltage. This is your voltage. Now what I am doing. This is the gain. This is the gain. Now you just see that output voltage is changing. Output voltage is changing depending upon the modulation index. You just see, you can notice that the frequency,
Yes, sir.
right? Frequency is changing. Frequency is changing. Likewise, modulation index is changing. Modulation index is changing. Means output voltage is changing, right? And where we got this variable gain? This variable gain is very useful, especially when you wish to this PI tuning and all. This variable gain is available in the Simulink block set. In the math, there you have variable gain. So what you can do during the simulation, you can change the value of any parameter by simply sliding here and there, right?
Okay, sir. Is it available at the MATLAB slider?
Yes, yes, it is available in the MATLAB. That is why I am saying कि MATLAB is very wonderful software. Look at this math operation. Just see, slider gain is there. There, here. And one thing I also suggest student, don't find here. What the student used to do, वो फटाफट इधर लिखा find करा. अरे just waste your time. Just waste your time. It is not wastage of time. Because when you understand that this block, why they have put it in this, you will never feel that which block should be used. Is it available in the MATLAB or not? You know the function of each and every block. I still try to learn MATLAB, but still so many things which is untouched by me. Because it is such a huge software. जो कुछ भी whatever we feel that it is useful for us, we check those things and remaining we don't use. Now this is the second control strategy. This is the second control strategy. In this, just see the waveform, how it is changing. Yeah, the same simulation I have run now. So look at this. Look at this. This is the over modulation range. This is the over modulation range. Right? So now 2 level is over. Now take some higher level. It will be more interesting. It will be more interesting. Just give me a second. भाई इसको मिनिमाइज करो, इसको बंद करा जाए, नो, देन इसको बंद करा जाए, हाँ अब ठीक है. Now let us open some different things. Actually, we have given time to our chief guest of the event, Professor Ashish sir. That is why I can't extend my session after 3:10. So just wait. Let's take the 5-level inverter operation. Just see how simple it is. The same motor is being used, but the only difference is at this side we have used two-level inverter. Two-level inverter. You can see this is one, same 135462. This is.
I think it is CHV.
You can say CHB, but if you remember CHB, in that CHB we use a bridge in every phase, each phase.
Yes, yes.
Right? But not in this fashion. It is a cascade of two-level inverter. You
I
just
think
see,
so somewhere I read
this
about modular MLI.
This is modular MLI. This is modular MLI, but it is not the exact replica of the CHB. In CHB, we use different topology. Means there is a bridge, and that bridge is connected to the. In every phase, we have connected one base circuit of single phase, not in 3-phase, right? But here we have connected 3-phase. And the other thing you should notice, here the voltage level is 300 plus 150, that is 450, and this is remaining 150. So voltage level is, net VDC is 600 volt. Net VDC is 600 volt. And again we have used two modulation strategy here. This is one for normal operation and two for acceleration, three for de-acceleration. We have also investigated our drive for this what we call transient state stability. So for that we have used, right? And this mode is selected by simply changing this value. This value. I have used this as a switch. The moment I will put this as a 2, it will operate as a the drive is accelerated. If we put 3, the drive is deaccelerated. So that type of simple logic I have made. Right? Now just run this simulation. It is normal operation of the inverter. Just run this and see the output voltage. Modulation index is 0.4. Level of inversion is 3. And just check the output voltage. This. This. Just give me a second. Just give me a second. Yes. Look at this. How beautiful it is. हाँ, अब ठीक है. Just see.
Sir, it is a 5 level?
Yes. This is 5 level inverter. But not operated at 5 level. It is not operated at 5 level. Modulation index is low, na? Look at this. Modulation index is low, only 0.4.
Sir, how to
Now-
set this modulation index? Actually, time is very less, so I have lots of questions. In modulation index, even I face some issues.
I tell you. Modulation index is defined as the output voltage upon input voltage. Right?
Yes, sir.
Or it could be output frequency divided by input frequency, something like that. So what we are doing, we are setting the voltage, right? And if constant V by F is constant, that value of constant is fixed. Once the value of constant is fixed, it means what? You can know the frequency because V by F is constant, F is V by that constant. So frequency no. Once the frequency is no, you can calculate the modulation index. Look at this. This is your V. This is your V. This is your constant. So from here you will get the value of your frequency. This will get you the value of your frequency. Now the maximum is this. Maximum is this. Output voltage is this. So output upon input is your modulation index. As simple as that. Now if we increase the modulation index, how we can increase? By simply make this gain high. Now let it run. Run हो गया. Now just see. Just see. Just give me a second. This is your VA. Look at this. Now it is operated 5 level inversion operation. At lower modulation index, it will go from 2 level to 3 level to 4 level, then 5 level. Right? It is go like this. Now you further increase the modulation index. Operate this. Operate this. and C. Where was the monitoring? Here it is the monitoring. You just see. Now it is converted into overmodulation range. It is converted into overmodulation range. You can notice some steps are now start missing. Some steps are now start missing. So it is converted into overmodulation range. Right? So this is
Okay, sir.
the 5-level inversion operation. This is 5-level inversion operation. Clear?
Yes,
Restricted
sir.
to 4 because some index are missing. You can see the modulation index is 1.15. Is it possible to have modulation index more than 1? No, it
No,
is
sir.
not possible. Not possible. So it is converted into over modulation range. And you can see how this level is generated and all. Simple triangular carrier, it is the 5-level inversion operation. So 4 carrier are compared with the reference wave, and depending upon the position of reference wave, it is being calculated. Look at this. Look at this. Oh, these are the pulses. तो ये तो 1 0 ही दिखेंगी. Where इससे पहले वाले में just wait. Here you can see these are the 3 pulses. Sorry, 4 triangular, and you can see why I was saying that this is the overmodulation range. You can see these are the beyond the triangle limit. These are the beyond the triangle limit. That is why some levels are missing. Right now, I think last 10 minutes hai, so let us touch the electric vehicle as well. And this type of drive is used in the electric vehicle. This open and winding induction. See, the main problem is with the electric vehicles are this battery. So battery has to be handled very properly, right? The size of battery has to be taken care of. So for that, this open and winding induction motors drives are now get popular for the EVs because they required half of the battery size can be used either way. So reliability is also get increased. Once the one side the battery or the some fault is occur at one inverter, you can connect it in simple induction motor and you can reduce the motor at lower power. So you are not get to stuck somewhere just because of fault of inverter. So that type of thinking people has developed nowadays, right? Now come to the this. Let us take some example related to EV. Just give me a second. तो इसमें तो ईवी वाला वहां पे होगा. हालांकि it is very difficult to cover within 10 minutes. So I wish कि आपको I mean if you have any doubt you can ask within 10 minutes. Within 10 minutes you can ask if you have any doubt. Because we are going to end the session at 3:10. So if you have any doubt, you can ask. Or if you...
Sir,
Yes,
sir,
please.
in last inverter, the design you have shown to me, I think MLI 5 level, what you mentioned, I think VYF ratio. If I will use in place of induction motor, open winding induction motor, if I will use the photovoltaic, then the VY application will matter.
Listen, I tell you what you have to do. Pardon. I mean, you want to grid do something with grid. You wish to feed the power to the
Yes.
grid? Okay,
Yes,
fine.
sir.
We can also do the same type of thing for this grid connected PV system. This I mean few months, 1 month back, I mean that thesis has to be sent for evaluation. One of my PhD research scholar, Raja Sachan, is doing work in this field. We have developed inverter which is based on this open and winding configuration. What we did this transformer which is used to feed power to the grid, that we use uh, open and configuration. Generally in three phase transformer, what you have three terminal and you just connect one inverter. After, I mean, converting from solar to that boost chopper, then convert using the inverter and feed power to the supply system. But here what we are using a transformer which is fed on both sides. I mean, the primary side is having its own two transformer, and that is feeding, and supply is feeding to the grid side on the secondary side. So they are the same configuration we have tested, and that gives a very good result. So no need to worry. If you wish to this open and winding configuration there, you can also use.
Okay, sir.
And this is the 9 level inverter operation. By using the same thing, you can see here two level inverters are here, and two level inverters are on the right hand side. Then this is the open and winding induction motor, and then
So
we
can
have
you
two.
share the paper? Actually, it's a quite interesting to know and to implement because
You
my
can
design is
you
basically
see, Amrita, you can see our website hbtu.ac.in. There you can go my profile. I'll share that link and everything to you, so you can see all the publication and everything detail from there. So you can take it from there for your reference, right?
okay, sir.
All this is already published now. Hmm?
Okay,
That
because
grid side converter is also,
my design is
yes.
basically all about the interleaf boost converter with the MLI.
Okay, fine. So you
Then
are
it is
basically
connected. Huh.
you are basically working on both sides, right?
Yes, sir. Yes, sir.
Right, you have to that improve the I think you are going to use this solar power to feed the convert grid side as well as load side both.
Yes, yes.
Is it something like that? So it's fine. It might be this configuration. If you use you good response from your guide as well. I mean, it's depend whether what your guide wishes to do in this particular thesis, right? Let me
Yes, sir.
once run this simulation so that you can see the 9 level inversion operation with simple. Meanwhile, I am also changing the value of this modulation index so that you can have the glimpse of all starting from 2 level to 9 level. Okay, fine. Let us see. This is the phase voltage waveform. Just see. Have a look from 0 to end. At this, modulation index was different. You can see the inversion operation is like this. If you calculate the TSD of this and you calculate the TSD of this, you will surely notice the improved output voltage. It is operated at 9 level inversion, or more likely it looks like sinusoidal. And this is the 2 level inversion operation. This is simple 2 level inversion operation. Right? So this type of things are here. And I'll show you the THT as well. Final result. And one thing more I would like to tell all you. Look at this. This time the solver is OD1 because we have to operate this in the discrete mode. We have to operate this in the discrete mode. Here you can see it is no longer continuous mode. It is discrete mode because it is developed on real time simulation tool, that Opel RT base. And Opel RT, they operate only on the discrete mode, not in the continuous, right? So you have to have the select the sample time. And you can notice we have selected 10 microsecond. We have selected 10 microsecond, 1 into the power minus 5. Now let us take the FFT analysis. This is your window. This is your window. Now, if you wish to do, start time is 0.6, number of cycle 5, display FFT window, this. And because I have taken this frequency, I have taken any at random value. That is why this TSD is high. Let me check here. Just give me a second. I'll show you. 320, if I am not mistaken. Let us take 320 and run the simulation, and the value of frequency is 40. Now we will check the TSD. Frequency is 40 Hertz. Just stop the simulation, check it. FFT analysis. FFT analysis 40. Check this. Oh, start time is 0. Display FFT. Display. It is 40 Hertz fundamental. Look at the TSD 7.97. If I start from 0.02, number of cycle 2, display, yes, 7.97%. 7.97%, and if I take this as 1,000, it will further show you the real picture. Look at the value of the dominant harmonic, 1.4%. Fundamental is maximum, there is no DC component, and the dominant harmonic is 1.4%. I'll show you why 7% TSD is there. Let us take this 5,000, then you will see why this is so high. It is order of 50. 50, order of 50. You can see the very small filter is required to eliminate this higher harmonic, which is contributing to 2%. So that is, subsidized at the using the small filter. So that is the good point of this topology, right? With this, I just want to tell you some project related topic which you can use in your BTech project for your student, right? See, nowadays everyone is looking after the AI, right? So we cannot say that it is of no use and all. But what we have to do, we have to use the AI wisely. You can tell your student, do project related to electrical engineering with using AI, like use of AI to finding the fault in multi-level inverter. See, the reliability is a great issue, great challenge, and you have to find that where is the faulty switch. So there, depending upon the waveform, your AI can tell where is the problem, right? So that type of thing you can say. You can use AI in the load forecasting for power system guys. If the load is like this, then you have to find the what is the load forecasting for tomorrow. There they can use this type of things, right? So, and for this grid integration system, solar related system, they can use AI, right? So that is the things which needs to be taken care of. And as yesterday I have also shown this. Now again, if you wish to connect me or our university, then these are the details of mine. You can scan my profile uh, available at Insta, or my WhatsApp number is also there, so you can have it. I have also given the QR code of my Power Electronics channel, where whatever the lecture I deliver here and there, I just put it there. Even this workshop recording is also available at that site, so you can take it, go through from that, right? So wish you all the very best. I hope all of you are get benefited by this workshop, and this is all about. And from my side, I have taken 2 minutes extra. I am very sorry for that to the organizer. Thank you very much.
Thank you so much, sir, for this wonderful session. Now I am sharing the feedback form in the chat section for session 4. Everyone kindly fill out this form.